Bismillahirrahmanirrahim. Welcome back to my channel. Another GNU Radio video, and in this video we're going to learn actually how to measure power. And everything is exactly the same. Basically, we're going to learn how to use complex to mag squared block. Basically, this allows me to actually take the amplitude of my signal and convert that into an average power or into a power signal, so I can make certain measurements, power measurements. So that's the demo, and let me walk you through the flow graph real quick. So let me just zoom in on it. So I have a signal source that is coming in. This signal source has a frequency, F0, amplitude, some amplitude value, some offset value, and then I'm using a variable called waveform. I already made in my previous video, I already used waveform. What this particular waveform allows me to do, I can select a GUI chooser like this, and from your repository here, and on this wave chooser, on GUI chooser, you can use options like 102 for cosine, 103 for rectangular signal, 104 for triangular signal. So you will have a drop-down block where you can select different type of signals that you want. That's why I have this chooser block. This chooser block is controlling what type of waveform I want. So you can just simply type in a waveform, and all the rest of them are same. You have a GUI slider for amplitude, for offset. You have some slider, and then you will also have a center frequency slider. So all of this is just being controlled here. Anything that is underlined in GNU Radio, you can zoom in. You can control it variably on runtime. Then definitely you gotta have a throttle block. You can omit this if you want. It was actually a previous flow graph, so I just threw everything into this flow graph. Just a low pass filter, nothing fancy going on here. I have a sample rate that I have set to be 32 kilosamples, and a couple of variables, which is going to be your frequency of your low cutoff frequency for this particular filter. That has a default frequency of 1000, starting from 10 all the way up to 10 kilo, and a step size of 1. This is the thing that is being controlled by this cutoff frequency. Transition bandwidth is just usually whatever that frequency is, 0.1% of that. So that's why I have chosen this frequency. So it's a low pass filter. You have a signal coming in. It's going to keep the frequency 1K, depend on the slider value, and it's going to reject all the rest of the frequency. This is actually, I was working with real numbers, so you gotta have complex to flow graph, flow to complex graph. So this is just a type conversion, and now this is the block that it does. So this is complex to mag squared block. So you have samples coming in. Mag squared basically mean, just remember this, mag stands for magnitude. When you think of magnitude, think of voltage. So what that is, if you remember it, the basic rule in engineering that we learn, that power is amplitude squared. So whenever you have amplitude, just simply square it, you will get power. That's the basic rule. So this is what that block is doing. Complex to mag squared block. Just take whatever the signal that you have coming in, or whatever the value of your magnitude is, just simply square it, and you will get the complex to. This is what this block does. Then of course after this we have a low pass filter. Everything is exactly the same thing is being controlled, and now the output is going into a number sync. Number sync basically gives you that average power display, so you can see it in terms of numbers. Alright, so far so good. These are just instrumentations that I've just plugged in. So you have your original signal, which is coming in, is going into a GUI time sync block. This is also going into a frequency sync block, and this is also going into a histogram block. So you're basically just monitoring whatever the incoming signal is. You're just looking at it. So after your low pass filter, you're looking at the same signal in your time sync, in your frequency sync. This is what you're visualizing. Also here, after complex to mag block, you're also visualizing your time signal. Alright, in time domain, then in frequency domain, and you're also looking at it in histogram. And the low pass output, the output of your low pass filter is being displayed at your number sync. That's all it is to it. So let me just run the flow graph and then have a look at it. All right, once I run this flow graph, all right, so this is the time sink before low pass filter, which is this one. So we're seeing a signal that has an amplitude which is going from 1 to 1. It has a frequency of 200. You have a low pass filter that has a transition bandwidth or a cutoff frequency of 1000. This is being controlled by a GUI slider. Nothing fancy going on here. This is the signal that you're getting before your low pass filter. So this is that FFT sink. And let's look at the histogram is also this before your low pass filter. Now we have three other sinks that are working. This is after complex to mag block. So this is the signal that you're seeing after square to magnitude block. This is what you're visualizing at. This is the square wave signal. This is the frequency sink, and this is the histogram sink. So far, so good. So let's have a look at it. All right, we have a signal that has an amplitude of 1. What type of a signal I'm working with? I'm working with a co-signal. I'm working with a what? I'm working with a cosine signal. And if you remember it, I already made a video on it when I was discussing measuring the power using Parseval identity and on Fourier transform. So I already made a video on it. So anytime you have cos and sine signal, if you want to find out how much power it is, of course, I think I worked out a mathematical process of that, but you don't need to know. The end result was basically whatever the amplitude is, amplitude squared divided by 2. That's the answer that we got. So amplitude squared divided by 2. That's it for any power signal which was cosine. I think I made a video on it where I have taken Fourier series where you have cos and sine, and we worked on it and we came up with a squared divided by 2. So if I have that same logic in my mind, if I do that, let's look at how much power do I get. So I think I just open up my calculator. So 1 squared is 1, 1 divided by 2, so 1 divided by 2. So my power should be 0.5. So let's have a look at it. And indeed, it is 0.5. All right, let's try another value. Let's say you have 0.5. Let's try 0.5 or anything less. Let's try 0.8. So 0.8 squared, so which means 0.8 multiplied by 0.8 equals, then divide by 2. So 0.32. Let's look at it in our number sync. Are we getting 0.32? Yes, exactly. We're getting 0.32. So basically, this is how you're going to use your complex to mag block. Let's try some other value. Let's try some 1.5. So 1.5, if I try it, 1.5 1.4 actually. 1.4 multiplied by 1.4. 1.4 equals divided by 2 and 0.98, and exactly this is what we're getting. This is what we're getting, 0.98 right here. So indeed, this complex to mag block does work. You can do measurements, and just remember that for cos and sine signal, because these are generally considered to be power signals, you can and I'm going to leave a link to that too. So it's just whatever the amplitude squared divided by 2. So I hope you like the small tutorial. If you have any questions, leave it in the comment section. Don't forget to like and subscribe to my channel, and thanks for watching.